Assalamu alaikum and a very good day I bid to Professor Zakia as well as Dr. Yazid. My name is Ahmad Muhsin bin Sazali, metrics number CD190113, and from group 3A, and we are going to do a presentation on our group project that is solar panel. Let's get into it. So this is the table of contents. This is what we are going to present to you, consisting of introduction, material, processing and manufacturing, selection of material, and lastly, the conclusion.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adib bin Muhammad Rashidi. My nominee is DD220027. So I will start with the introduction. The solar panel, a groundbreaking project integrating solar panel with science materials, offer a clean, sustainable, and endless source of power. This innovative approach to sustainability and environmental consequences aims to reduce carbon footprints and address climate change by converting sunlight into electrical energy. For solar panel, our project explores solar panel interaction with material science, focusing on photovoltaic qualities and energy conversion. It aims to integrate solar power with new materials for scientific research and sustainability.
Okay, next, let me present about material selection for our project. But first, let me introduce myself. Okay, my name is Syahmirza bin Samsul Bahari. With metric ID is 230059. Our first material is crystalline silicon, the backbone of the solar panel. Ours is significant to the order arrangement of the silicon atom. Its unique chemical and physical properties make it an excellent semiconductor, capable of conducting electricity. Our ongoing efforts in the crystalline silicon technology focus on enhancing the efficiency and reducing the cost of solar cells, which are pivotal in the realm of renewable energy. Innovation include improved surface and passivation methods, thinner wafer, and the development of tandem solar cell. Okay, now let's turn our attention to cadmium telluride or CDTE, a key player in thin film photovoltaic solar cell, known for its high absorption coefficient and cost-effective manufacturing. CDTE-based cell offer an attractive combination of efficiency and affordability. However, concern about the environmental impact have prompted researchers to explore alternatives and improve recycling procedure. Despite this challenge, CDTE remains a focal point to innovation in photovoltaic with continuous effort to enhance stability and efficiency. The last material that we choose is thin film solar cell, specifically those made from copper indium gallium CIG combined with the sulfur or selenium have gained popularity for their efficiency and flexibility. This cell formed by mixing these elements with sulfur or selenium offer high conversion efficiency, cost-effective production, and the unique advantage of integration into building materials. Now, let's break down some key components that play pivotal role in solar technology. One is copper, which is Cu, increasing the material conductivity. The second one is indium, which is In, boosting light absorption and solar cell efficiency. Third, gallium, which is Ga, aiding in enhancing the material electrical characteristic. Okay, number 4, selenium, which is Se, frequently mixed with gallium, indium, and copper to create GICS. It performs a vital role in the photovoltaic system. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Halimatus binti Durasat with matrix number CD230200. So I would like to present about processing and manufacturing. So based on our project, we have identified three manufacturing and processing methods. So the first one is chemical vapor deposition. Chemical vapor deposition (CVD) is a widely used process in solar panel manufacturing where thin film or coating are deposited on a substrate through chemical reaction. The second one is deposition of thin film. Thin film layers for solar panel are created by applying semiconductor materials onto a substrate with different thin film technologies employing specific method and materials. And the last one is silicon purification. Silicon purification is a crucial step in the manufacturing of crystalline silicon solar panels. The goal is to obtain high purified silicon as impurities can significantly affect the performance of the solar cell. Next is chemical vapor deposition (CVD) process. First step is preparation of substrate, and the second one is introduction of precursor gases, and third one is chemical reaction. Next is deposition onto substrate. The thin film thickness and properties can be controlled by adjusting process parameters such as temperature, pressure, and precursor concentrations. And the second one is film growth and annealing. Process may involve multiple layers. The substrate may go through annealing process to enhance the film quality and properties. And the last step is processing steps. After deposition, additional steps may be performed such as etching, patterning, or adding other layers to create specific structural and functionalities needed for solar cell applications.
So let's look at the application solar panel manufacturing right now. So there's silicon deposition, there's anti-reflective coatings, passivation layers, transparent conductive oxides or TCO, and lastly the thin film solar cells. So the second part of our processing and manufacturing process is deposition of thin film. So let's look at it. Involves the application of various semiconductor materials onto a substrate to create the active layers of the solar cells. So there's three. Number one is amorphous silicon, ASI, thin film solar cells. The second one is cadmium telluride, or CDTE, thin film solar cells. And the third one is copper indium gallium selenide, or CIGS, thin film solar cells. So as you can see at the bottom there, that is the process of deposition of a thin film. So the first one, A, is fabricate TFCS, And the second step is to peel it in water bath. And the next step is to place it on the target. And the last step is remove the holder. So the third part of our processing and manufacturing is silicon purification. Now let's look at it. There's about 8 of it. So number one is raw material extraction, carbothermic reduction, Siemens process, fluidized bed reactor FBR process, zone refining, Chokhralski method, float zone method, and wafer production.
Selection of material. In selection of material, we need to compare the crystalline silicon, cadmium telluride, and also copper indium galliums that are commonly used for material for solar panels. So CDTE cells achieve efficiency between 9% and 11%, while CIGS cells can reach to 15% to 24%. CDTS is cost efficient but has environmental concerns, while CSIE has lower environmental impact. So the best material is silicon, crystalline silicon, and also the process is silicon purification is the most suitable process of CSI, as the other two processes are designed for the thin film. Advantages of silicon purification for CSI. So the advantages is high efficiency in solar cells, can improve electrical conductivity, reduce combination losses, enhance light consistency, consistent energy output, extended lifespan of solar cells, improve mechanical properties, optimize manufacturing process, and last but not least is lower production costs in the long run. So this is our financial plan, which is the cost estimation of the silicon purification method. Okay, so this financial plan is created to for 1,000 crystalline silicon particles that can that has a size of 4 cm by 2 cm. So the cost is uh, we can divide it in 5 different operating costs, which is energy consumption, labor costs, maintenance and repair, quality control and testing, and also raw material. And the total of the cost would be 52,000 ringgit. And so since the expenses of the since the op- operating cost is 80% of the product, so the price of our crystalline silicon solar cell would be around RM65 ringgit per pieces.
Okay, so I will continue with the conclusion. For the conclusion, the study explored the potential of solar panel and material in promoting sustainability and science research. The solar panel interface demonstrates the synergy between clean energy and material science, maximizing renewable energy possibilities and opening new avenues for innovative research and educational engagement. Solar panels offer hope in tackling climate change. Solar panels are also a symbol of innovation and clean energy, reducing greenhouse gas emissions and reducing dependence on fossil fuels. They offer energy independence and require less maintenance. However, they have financial challenges due to high initial installation costs, require energy storage options due to intermittent sunlight, and pose land uses and aesthetic issues. As technology advances, solar panels represent a commitment to a sustainable relationship with the environment. So that's all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
And by ending it with a conclusion, that is it from us, from Group 3A. Thank you for your time and thank you for watching.